Hi everyone, in this video we would like to simulate the PV cell and obtain the VI characteristics for this cell using the MATLAB. So we are going to get the voltage, current and power characteristics according to the variation inside the radiation. So the first thing, we are going to create a new Simulink. So new, then Simulink model. Now we need to add some components. So the first thing we would like to add is the solar cell itself. So we are going to the Simulink or the library browser or Simulink library. Then we are going to type solar cell in the search term, solar cell. So now we have the solar cell, which is inside the Simscape library inside the Simulink. Okay, so this is a library inside the MATLAB itself. So double click and add it to the model untitled. Okay, this model you will see here having the solar cell like this. Okay, so we have here our solar cell and the two terminals of the solar cell, the positive, as you see here there is a positive and the negative, and here the radiation is going to the solar cell. So we need to add the constant which representing the radiation going through this cell. So how we can do this? Simply by going to the Simulink library, then typing constant, then going down to the Simscape. Okay, where this constant. Okay, since this one is from the library of the Simscape, this one, therefore we will have to get a constant which is from the same library. Okay, this is from Simscape library, therefore this constant will be from the Simscape library. Simscape library simply deals with physical components. Okay, physical components we would like to simulate inside the MATLAB. So right click and add to the model untitled. So now we have our constant. This constant representing the radiation from the sun. Okay, radiation from the sun going through our cell. So we'll take here the output like this and connect it to the solar cell as if it is the radiation. So what is the value of the radiation? We are going to draw the voltage current characteristics with the different radiations. So we'll assume that the radiation here is 1000 watt per meter square. Okay, apply, then okay. So this is the 1000 is the amount of radiation falling on the solar cell. Now the second step is that we would like to add an ammeter in order to measure the current here, and we would like to add a voltmeter in order to measure the voltage across the load, but we would need to add a variable resistance, okay, which is representing our load. So if we look at the library for the Simscape, you will find that we had a variable resistance. Okay, where is the variable resistance? Okay, let's type it, resistance, enter, then search for the Simscape, and here we have our variable resistance. Why we are using a variable resistance? Because we would like to get a variable load. We would like to change the load itself, the resistance of the load, and see how it will affect the voltage and the current of the solar cell. Okay, because the variation of the load will change the VI characteristics. So let's see what will happen if we add the variable resistance. Add to the block model untitled. This one is called untitled model in MATLAB. Then Control R to rotate this symbol or this component. Then we are going to take the positive connected to this variable resistor and the negative to it. But before this, we need to add the ammeter in order to measure the current. Remember that this one is BS, semiscape, this one is semiscape, this one is semiscape. All of them can be connected together because they are from the same section, the semiscape part. Okay, now I would like to add an ammeter. So the ammeter inside the Simulink here can be considered for the semiscape. It's called the current sensor. Okay, current sensor. Then enter. Okay, current should be here E. Current. Okay, this one is also from semiscape library. So we are going to use one current sensor. Right click and add to model untitled. Add block to the model untitled. Now we have our current source. So not current source, the current sensor or the ammeter. Now we would like to connect the current goes out from the cell through the current sensor, then through the variable resistor. So we will take this terminal and connect it here, and the second terminal here, and connect it here. Remember that the value of the ammeter can be taken out from here, from I here. Okay, now we need also a voltage sensor because we would like to measure the voltage across the load. So going here and typing voltage sensor, voltage sensor. Okay, enter. So we have here our voltage sensor. Right click, then add block to the model untitled. Now we have our voltage like this. Now our voltage have two terminals. One which is this one, like this, which is measuring this part, and the other terminal to measure this second part. Okay, and this is the output of the voltmeter. This is the output of the ammeter. Now our solar cell will be connected to the other terminal like this. So we have solar cell providing power through a current sensor to the variable resistor, which is considered as our load, and then to the voltage sensor measures the voltage across the load. Now the next step is that we would like to add the grounding for this part. So going to the library and typing ground, then going down to the semiscape again, you will find here electrical reference. Right click, then add block to the model untitled. So we have here our electrical earthing. Then connect this terminal to this part like this. So we earthed or provided an earthing node to our cell because this one is the highest voltage with respect to the ground or zero voltage. Now the next step is that we would like to add a block called the solver configuration. Because we are dealing here with a semiscape, so we will need to add a solver configuration to this model. So let's add the solver. Then going to semiscape like this, solver configuration, add it to the model untitled. Then we'll take this one. Okay, then connect it here to this part, double click on it, then use local solver, then apply and okay. Now the second step is that we would like to add the power sensor. Okay, we have the current, we have the voltage, and we need also to add the power. So we need a product, okay, because the power produced from a solar cell is equal to the voltage here across the load multiplied by the current going through the load. So we'll go here to the product, product in order to multiply the voltage and current, then add to the block. Now you will notice something here, that we have the product here like this, and we have a problem here. Now if we connected the current here, you will see that it is not be able to connect to it. Why? Or even the voltage, if we take the voltage like this and add it to this block, it cannot be added. Why? Because these two are from Simscape library, but this one is from Simulink library. So we'll delete this and delete this. So we need something to change the signal of the current source or the current sensor from being a Simscape to a Simulink. So how we can do this? So we'll go to the Simulink library again, then type converter. Okay, enter converter, there is an E here. Okay, then go to the Simscape. You will find here in the Simscape that we have a Simulink to a Simscape converter, or a Simscape to Simulink converter. So we have two types of converter. One can change from the signal of the Simscape to a Simulink, and this one it changes from the Simulink signal into a Simscape or a physical signal. So what we have here, we have a physical signal, which is from the solar cell, physical signal from the current, and physical signal from the sensor, the volt sensor. So we need to convert this physical signal to a Simulink signal. So physical, which is the Simscape, into a Simulink. So add to the model untitled. We have this one here. Then connect this one, the current, to this part. Then from the Simulink to the product. So we converted the Simscape or the physical signal into a Simulink for simulation signal. Now we need to do the same for the voltage source. So we will just right click, okay, and copy. Then right click and paste. Now we have the voltage converted to a Simulink signal. So now we have the output of this one is the power, and output of this one, this part is the current as a Simulink signal, this one as a voltage Simulink signal. Now we need to add a workspace in order to store the values. Okay, so workspace for the voltage, workspace for the current, workspace for the product or the power. So going like this to the Simulink again and typing workspace. Enter. Going to the Simulink, you will find here two workspace. So add block to the model, this block, and we need one for the current, one for the voltage, and one for the product or the power. So we will just select it, then control and drag to duplicate it. Double click, then name it as the current. Then OK, double click, voltage, OK, power, OK. So we have power, which is the output from here to here, current from here to here, which is the output of the converter, the voltage from here to here, the voltage. Okay, let's delete this, the output here. This is after converting from a physical signal or from Simscape to a Simulink signal. So we have the current, the voltage, and the power. Now what is the thing remaining? The last thing remaining is two things. Number one, we need to store these values. So whatever the change in the current when the load changes, I would like to save the values of the current, voltage and power for the corresponding value of resistor. So how we can do this? Simply by double click on the current, we will click on save format as an array. Okay, save this one also as an array. We would like to store all of the values when the resistor changes. An array. Okay. Now what we need to add? We need to change the variable resistance. We need to change it. So how we can change it? By adding a ramp input. Ramp like this. So we'll find that it is a Simulink. So add to the model untitled. So we have our ramp. Now the ramp here, I would like to change the from 0 to 1. Okay, start time 0 and the slope equal 1. Okay, now when we connect it to the resistor, in order to change its value, we'll see that it cannot be added. Why? Because the ramp here is a Simulink, but this one is a physical load or a Simscape load. So we'll delete this one. So we need to add the converter. So converter, in order to change it from Simscape to a physical or from the Simulink to physical. So from Simulink to physical, add to model untitled. So this one is a Simulink, going here, Simulink converted to a physical value, then through the resistor. You'll find it is connected now to the resistor. So what does the ramp mean? It means that it changes from 0 to the maximum value. We are changing it. Okay, we are increasing our load gradually and storing these values. So we have first the radiation at 1000, the solar cell. If you double click on the solar cell, you will find here the different characteristics, the temperature and everything you would like to add about this cell. Okay, you'll find short circuit, open circuit, the radiance and so on. Everything you would like to add, you can add it here in order to simulate your own solar cell. And you'll find here the equivalent equation for this block diagram. Then clicking on OK. Now we can simulate this one by just clicking on run. So we simulated at 1000. Now if we would like to change it at 900, then we would double click here and make it 900, then OK. Then after this, okay, we have current, voltage, power. Okay, these are the parameters at 1000 watt per meter square or at irradiance 1000. Now if I change it 900, then I need to change this parameter, the storage variable. Current number 1, voltage number 1, power number 1. Okay, so these are the three variables which will store its equivalent values at 900 watt per meter square. Run. Again, change it to 800. Okay. Current number 2. Voltage number 2. Power number 2. Then run. Now we have it 100. Let's make it 700. Okay. Number 3. Voltage number 3. Okay. Power number 3. Okay. Then run. 600. We are going to do this until 500. Okay, and you will see the results, and when we plot them inside the MATLAB. Okay, each irradiance or each variation inside the watt per meter square, we are giving it a different variable for the voltage and different variable for the power. Run. Last one, 500. Okay, going here, current number 5. Okay, voltage number 5. Okay, power number 5. Okay, run. So now we obtained for 1000, for 900, 800, 700, 600 and 500. So we have 6 different values for voltage, current and power at a different irradiance. Now we need to draw the voltage current characteristics and the voltage with the power. So how we can do this? Simply we go to the MATLAB itself, back again, and you'll find here inside the workspace current 1, 2, 3, 4, 5, power 1, 2, 3, 4, 5, and voltage 1, 2, 3, 4, 5. This is the values which we would like to store inside our MATLAB. Okay, we stored by simulating at different irradiance. Now I would like to plot them. So we will type in the command window plot, then bracket. We need to plot the current, okay, or the, let's make it the voltage, current, then the voltage number 1, voltage 1, current 1, voltage 2, current 2, voltage 3, current 3, voltage 4, current 4, voltage 5, current 5. Okay, so we have the 5 different values. Then we will close the bracket, then enter, and you'll find what will happen here. You will find here the 5 different values. We say voltage current, it means that the X is voltage and the Y is current. Voltage is X, Y, X, Y, X, Y. So we'll find here 1, 2, 3, 4, 5, 6. This is 6 different values for the voltage across the current. Okay, this is the voltage and the current and its a variation with respect to time. Okay, now the question is how I can name this figure, name here and another name here, the X and Y and the window itself. So we can go to the MATLAB again and type X label, bracket, then 1 colon, then we would like the X to be the voltage. Okay, voltage. Okay, then close the bracket, enter, Y label, then bracket, colon, then make it the current, enter, and finally title, bracket. I would like to name it as VI characteristics. Okay, VI characteristics for PV cell, then close the bracket, but at the beginning we have to add this one and this one. Okay, then enter. Now let's look at the figure now. You will find here VI characteristics for PV cell, which is the title here, and the x-axis is named as the voltage, the y-axis is named as the current. Very simple and very professional in looking. Okay, so now we will need to plot the voltage and the current. So type plot, then voltage with power, voltage 1 power 1, voltage 2 power 2, voltage 3 power 3, voltage 4 power 4. Now we are just we would like to plot the voltage and the voltage with respect to the power at the different loads. Okay, to see the variation of the load or the voltage with the maximum power. Voltage 5 power 5. Okay, we have 5, then enter. Okay, let's see the plotting. You will find here the plotting. You will find here the variation of the voltage and the equivalent power. You will find that at a different irradiance, as the radiation increases, you will find that the equivalent power increases. Okay, at the same voltage. At the same voltage here, the maximum power increases as the irradiation increases. So you can also add here the title X label. Again, let's name it as voltage, and Y label as power, and title name it as VB characteristics for PV cell. Like this. Enter and see again. You will find here VB characteristics for a PV cell, the power and voltage. So in this video you learned how I can take a solar cell and get the VI characteristics and VB characteristic using the MATLAB program. So I hope you benefit from this video and see you in another lecture.